General tensor notation and terminology. The number of subscripts, that is the number of basis vectors of a tensor, is called the rank of the tensor. The number of subscripts that we use. For example, a scalar has no basis vectors to describe it, so it's a tensor with rank 0. When we have a vector, we just need one subscript. It is vi ei hat. Only I subscript is necessary. It's a tensor with rank 1. And if I use this double line on top, sigma tensor, this means it's sigma ij ei hat ej hat. It's a tensor with rank 2. So in general, if I have a tensor T, this can be written as Tijk, as many as we need, ei hat, ej hat, ek hat, etc. So we can have any rank tensor in principle. Now these ijk can take values, a certain number of values. So the number of values these subscripts can take, I, j, k, can take, is the dimension. It's the dimension of the coordinate system that we work in. For example, if this is a three-dimensional coordinate system, then we must have I, j, k values, or any number of the indices. These should have values 1, 2, 3, etc., depending on the number of ijk values that we have. But it's going to have 3 values because it's three-dimensional. Okay, so we talk about the number of subscripts. That's the number of basis vectors we need to describe a quantity. This is called the rank. Scalar is a tensor with rank 0. A vector is a tensor with rank 1. And here is an example for a tensor with rank 2. In general, you can have any rank that you need to describe your situation, but these subscripts I, j, k can take a certain number of values. For example, if I is 1 or 2, j is 1 or 2, k is 1 or 2, it would be two-dimensional. So if they can take values from 1, 2 to 3, then it's going to be corresponding to a three-dimensional coordinate system. So that's also going to determine the number of basis vectors you would need in order to describe the situation. All right. So now we have generalized our concept of tensor, and our tensor notation for any rank tensor is written this way. And remember that this is not an operation between the basis vectors, rather it describes a bin. For example, this is the ijk bin, where we have a number.